explain what that means.
Yeah, so it all kind of like revolves around this one in
It
a
sure
way.
does. And you have parents. We all have parents, and we kind of look like our parents to some degree. So
Mhm.
that's kind of the analogy here is like the graph you make should look like what you're
That
starting
one.
with.
I
Okay.
actually kind of like that analogy. It's when I can like understand.
Yeah. Um, and so like, and it's like same thing with cars. Like if you are you into like Mustangs or Challengers or Camaros, like what's kind of your muscle car that you like?
I like those old Mustangs, I guess.
Okay. So like over the years, they kind of still look the same, even though they're different. They've been
Yeah.
transformed. It's kind of the same idea here. So um, we're going to start making a table, and hopefully this is made really clear here. So you always choose 5 numbers for your table, and we're going to talk about how to choose those at some point, but not right now. And and you get these values by actually putting this number x in here. So it's parentheses -2 squared, which is 4. -2 times -2 is 4. And then the next one is parentheses -1 squared, which is 1.
Hmm.
Y equals, now when it's positive, you don't have to put it in parentheses. You can if you want, but it's 0. Y equals 1 squared, which is 1.
I
Y
also
equals,
actually have a question.
go for it.
So it goes from -2 to +2. Is it like, is that just like the formula for it? Like it's always -2 to 2 for like the parent function? Or
No, no. For this one, it is, and that's going to change on some other things. But it's like when you learn, you only want to do one thing at a time, change
yeah.
one thing at a time. So I'll address that when it comes up.
Okay, I was just wondering because like I don't know, math teacher's a little bit confusing. So like I kind of asked her that and I just really didn't get a clear answer. But
Yeah. Um, I hope my answer was clear, not an
yeah,
avoidance
I
of
understand.
it.
Because I
Um,
was thinking like before, those are like the only ways you can do it is just -2 through 2.
so on the right here, do you understand how I converted the x and the y into ordered pairs?
Yeah, I do.
Okay, great. Now I'm gonna just shift to the right here. I'm gonna make a new graph. Let's see if I can't, why can't I get over? There it is. So I want to make a new graph here so you can see this because it's really critical that you see the shape of this graph. And I'm not an artist. I'm not sure how your art abilities are, but we want to
Yeah.
make smooth curves and smooth connections here. So the everything you're doing in this unit, I'm just going to you're looking at this function which is called a quadratic. It's also called
Mhm.
a parabola, and perhaps the most descriptive is U-shaped. Okay, did you see or hear any of that in class?
I think I might have heard all of those except
Parabola,
yeah.
parabola. Okay, so a couple things about the graph here. It is not straight line connection. See how there's some curvature here to it?
Hmm.
Mention the cars, like we don't want a boxy looking thing here. We want a nice smooth curve to
Yeah.
this. Okay. Another thing is you got to have the arrows. The arrows indicate the direction.
Hmm.
All right. So this is what you have over here on the left, but you can see we want a little bit more lines, and then it's this like
And then also like label the numbers and
yeah. I mean, I'm not big on that, but like sure.
there's also one thing about when I was doing this, there was like for the other ones, there's kind of like there was like two lines. Is the original line just going to be like this parent function?
It's always going to be this. So what I'm going to do for our lesson today is I'm going to copy this one down every time and compare it to that,
All right.
so you can see what's going on. Okay. So if it's okay with you, I'd like to move on to the next
Yeah. So
function. Okay.
this is like this is like the basics. It's like 2 + 2.
Yes. Yes. So baby steps. You gotta move one step at a time. So this sometimes you see it this way. They say Well, I'll wait till you do that. Do you have any idea what this does, what the transformation is, whether it's up, down, left, or right based on this or not?
Um,
It's okay if you don't. It's just asking where you're at.
okay, I have notes on that. It's
Well, let's not look at the notes. Let's
all
do
right.
some self-discovery here. So let's go move down here. We're gonna make another table,
Same,
same values here. We're gonna go
I'm pretty
X.
sure it's the same thing, but it's moved over twice, like twice on the x-axis. Instead of being 0, it would be like 2.
Okay, so let's confirm that by going through the numbers here. So it's y equals, whenever you have a negative number, you always want to put it in parentheses. Okay, so it's -2 squared. That's -2 times -2. What is that value?
+4.
+4 plus 2 is
6.
okay. And then the next one here is -1 squared plus 2. Can you tell me that value, please?
3.
It's 3. And the next one here, so zeros and positives, you don't have to put in parentheses. It's 2. You will be expected to do this on your own. I know I'm rushing through it a little bit here with you, but you can follow this on your own. So again, what I'm going to do here is I'm going to grab this graph, and I'm going to let's paste this in here, and let's see, we can move it. That looks pretty good right there. Okay, so in a different color here, we're going to graph the ordered pairs. What is the first ordered pair that you see?
It's -2 and 6.
-2 and 6. So that's here. That's -2 comma 6. Then it's -1 3. Okay, and then it's 0 2. It's a little bit harder to say 0 2, and then it's 1 3. And then it's 2 6.
Up 2 because the 2 is a y in this situation.
The 2 affects the y value, yes. Okay.
So then it goes 2 up.
So the transformed image, okay, is in this case you go up 2 units or 2 spaces.
When graph moves, it's called So my question is, like, when I answer these, should I fill out my graph like that where I have the transformed and the original? Well, obviously I need the transformed, but should I also just keep the it's called the family or something, right? I can't remember.
Well, it's a parent. Yeah, it's a family of curves is probably what your
Family of
instructor may have
curves.
said.
So should I keep or the one on the 0 0?
The only okay, so I'm gonna try to answer your question carefully. The A plus student would show the parent and the transformed every time.
All right.
And the instructor wants that, but more importantly, they want you to understand what is happening.
All right.
Okay. Now I don't do you have this down, these notes down?
Yes, I do.
Okay, so I'm gonna actually do a new share here, and you're gonna tell me. I hope you've seen this before. I'm sharing my screen. Have you seen Desmos Calculator before?
I don't think so.
Okay, you're gonna really like this, I think. Okay, so can you clearly see on the screen here y equals x squared?
The
yes, graph of that.
Y minus x squared.
Great. Okay, so we're going to make a couple of changes here. If I could just remember how to do that, that would be great. Settings, there it is. We want to change that. We're going to make that black for our parent function. We're happy with that. Okay, so now you just graphed x squared plus 2. Okay, and do you see how it went up 2 units?
Yes.
This point right here, we're up right there. So now I'm going to not graph it. What if it's x squared plus 4? What do you think is going to happen?
It'll move up to the 4. Move up 4 units.
Move up 4 units. There it is. Okay. Now, let's say I go -1, what do you think is going to happen here?
I think that the unit will go down to -1. In
Does.
the bottom of the curve, that's called the vertex.
Well, actually, every key point on the graph moves down, and that is true. That is the vertex.
All right. So the
But like,
vertex would move down 1
but
unit.
here's a point on the original graph.
Mhm.
So if it moves down, okay.
Then it'll become 2 and 0.
So it's just moving. It's moving down, moving down.
All right.
Do you see that?
Oh, 1 0. Oh my gosh. Yeah, I don't know why.
Okay. So now watch this. I'm gonna undo a couple of things here. Okay. Plus K. So you've probably seen that before. Plus K. Is that
I
right?
have seen that one.
Okay. So now it's okay. So we're gonna do some animations here in just a moment. Okay. So let me see if I can get this to do it. I'm gonna hit play. And I guess there it goes. I don't know if maybe that's too fast. I don't know how we're doing on this.
Yeah, it's doing fine.
Do you see what's happening there when K changes?
Yeah, it's going up and down, and then the units, along with the whole thing moving, the units on it change. The 5 points on it change.
Yes, exactly. Okay. So like to summarize, what you have to be able to do, and let me pause this because it's distracting me, is you have to know that if it's plus a number, it goes up, and if it's minus a number, it goes down.
All right, that's not too hard.
Okay. Now, but there's a lot of these that you got to remember. So what I'm going to do is just switch back to that and just write that down, kind of summarize it, and then we'll go back to the Desmos. It's actually my favorite things to show students because it's so clear and interactive with the graphing calculator.
Yeah.
So if it's y equals x squared, y equals x squared plus k means you're going up k units.
Mhm.
And if it's y equals x squared minus k, you're going down k units. So this is sometimes summarized in one line.
Mhm.
And this may be how you want to remember it, because k can obviously be positive or negative. You just say up slash down k units.
All right.
Is that okay?
Yeah, and man, I still can't draw that like weird squiggly line in between them.
No problem, no problem.
Um,
But like this is your like, okay, I summarized, this is the first 15-minute summary of our lesson today.
Yeah.
So now let me know when you get back, get this down, because I want to jump back to Desmos and do some more
All right,
graphing.
just wrote it down.
Okay, so I'm going to new share.
And then
Yeah.
another thing I was seeing that's kind of like that, it's where the negative goes to the right instead of the left, and then the positive goes to the left
Yes.
instead of the right.
Yes. So we're gonna come back to some labels and some stuff like this. But for right now, we're gonna graph the following. We're gonna graph parentheses x minus 3 squared, and you're gonna notice that it moved to the right 3 units. Do you see that? It went right 3 units.
Wait, could you redo that? Sorry, I wasn't looking at that part of the screen.
So there's the original.
All right, original.
There's the
Oh,
new
all
one.
right.
So I moved to the right 3 units. Now that is often bothersome for students because it's -3. And we just said negative goes down. So you might
Yeah.
think that -3 moves it left, but in this case, it actually always moves it to the right.
All right.
So this is uncomfortable. This is awkward. This is like that thing where it's like it goes against the grain. So what do you think x minus 5 will look like?
I think it'll move over to the right 5 by 5.
By 5. Okay. So I actually should have changed this. The vertex is at 0, 0, and the new vertex is at 5, 0. You can see that there. right? So now, what do you think happens if we go the other way? Let's say we say plus 2 inside parentheses. Which direction do you think it's going to go?
It'll go to the left 2 times.
Right. And that's really awkward again. Like, wait, it's plus. Shouldn't it go right? Hey, it's, shouldn't it go left? And yeah, sorry. And so it moved left, it moved right. It's based on what's happening inside parentheses. All right, so now let's watch this happen. So I'm going to go x plus k, and then this changes the value plus k. I'm sorry. Excuse me. These things labeled here 0, 0. We'll label it, and then we'll go 0 plus k. Label that, and hopefully when we play it, oops, I got this going the wrong way. Sorry. All right, there we are. So we'll play it. You can see it moving, left and then right.
All right.
Okay. So do you feel like you understood this in its own sort of vacuum space?
I understand that. I understand, like when it's in the parentheses like that, it has to go to the opposite, and it's not going up or down, it's going right or left.
Right. So now let's go back to our notes and let me try and summarize.
All right. I do have one question about, so there's like 5 points on it.
Yes.
My main thing is like I don't really understand how the like points work super well on it.
Yes, I think we have time to address that today. You mentioned it twice. I really want to get to that. Just give me like just another few minutes if that's okay.
Right, awesome.
So let's say it's y equals x minus k squared. This is k units right. Okay. And then if it's y equals x plus k squared, it's k units left. Like it's completely backwards from what you would think. But that is what it is.
Why?
Like that summarizes it completely.
All right, that's a pretty good note to have. K squared.
Just give me just a moment here, please.
Yeah, of course.
Okay, is that you got that down?
Yes, I do. I do have it down. Oh, are you there?
Hey, so the next thing, what this leads to is like, are you able to, if I give you 2 transformations, so there's your parent, and I say y equals x minus 2 squared plus 3, can you tell me the 2 transformations? And this is the first one here. Oh, I'm sorry. I misspoke here. This is the first one inside parentheses. What does minus 2 do? And I'm going to just tell you, it goes 2 to the right.
All right, 2 to the right, and then that 3 is a y.
So it goes 3 up.
3 up, so 2 to the right, and then 3 up.
Yes. Okay. So let's try another one here. Let's say y equals x minus 4 squared minus 5. What are the 2 transformations here? And the order that kind of matters, kind of doesn't. Okay. So this one's first though.
The 4, you have to move it 4 to the right and then down 5 because it's not in the parentheses.
Okay, very good. Let's do another one here. y equals x squared, and let's say it's y equals x plus 1 squared minus 2.
X plus 1. Okay, it'll have to go to the left 1 and then down 2.
Very good. Okay. And the next thing here, this is the last of the 4 here, is it's x plus 3 squared plus 4.
Okay, so it's gonna move to the left 3 times and then up 4 times.
Yes, up 4. Very good. Okay. So we can finally address your question, which I think is really important. I'm going to do it in the context of a few more transformations. So let's say we're looking at y equals parentheses x minus 5 squared plus 1. What are the 2 transformations on this?
5 moves to the right, or it moves 5 over.
5
and
right,
then it goes up 1.
and up 1. Very good. Okay, now this kind of leads to the vertex. The vertex is the transformations.
All right.
Okay, so why is that important? The x value of the vertex is where you center your table.
The x value. So I guess that's important since that's where you're gonna know where you're gonna like put all of your points.
Yeah.
Or base it all off of.
Yeah. Okay, so what I mean by that is 5 goes right in the middle, 3 then 4,
All
6
right.
then 7.
So then,
So notice it's not minus 2, minus 1, 0, 1, and 2.
yeah.
Okay, it's 3, 4, 5, 6, 7.
So 2 before and 2 after.
Yes, exactly. That's perfect. So would you mind trying to fill in this table for me?
Yeah. 3, 4, 5, 6, 7. Would it just be the y equals parentheses squared?
So are you talking about the first one?
Yeah.
So parentheses 3 minus 5 squared plus 1.
Okay. So I'm assuming you have to solve the 3 minus 5, which is
Yeah, you do it's inside parentheses first. Okay.
so
Yeah, I
then
didn't.
-2, so it'll move to the right 3 times.
No. We're done with that. We're done with that.
Oh, okay.
Now it's just evaluating it.
Okay, I think I got the rest then.
So can you give me like I want to get the 5 values here, the y values.
Okay, I guess
I'm asking you like what is 3 minus 5 squared plus 1?
5.
Yes.
Okay.
And then
Okay.
the next one here, 4 minus 5 squared plus 1.
Just that would be just 2, I think.
2, very good. And then y equals 5 minus 5 squared plus 1.
Ooh, just 1.
Just 1. And then y equals parentheses 6 minus 5 squared plus 1.
That would also be 2.
Okay. And then the last one.
2, 4, 5 again. Oh, so it works with all of them.
There's symmetry. Yes, very important. There's symmetry. Okay.
Okay, wait, that actually makes sense because those are all.
And it actually happens that these are the same and these are the same because they're equidistant from the vertex.
Yeah.
Okay, so let's do another one of these in the context of transformations. We'll make the table again because the question you're asking is a really important one. It helps you figure out, how to actually graph this thing. So let's say I give you y equals x plus 2 squared plus 6. Okay. So give me the transformations. There's 2 transformations. What does the plus 2 do?
The plus 2 goes to the left 2 times.
Left 2, and then the 6?
It goes up 6 times.
Up 6. So this actually tells you your vertex. Your vertex left 2 is
Six.
-2, comma 6. I
So
don't know.
if you're given that, so that like problems like that will be like just given, there will be like an empty table and then an empty graph.
Probably. Yeah. At some point, you're going to have to graph these on a test or quiz. Sure.
Yeah. Okay.
Okay. So now so this is very important. This X value centers your table.
Centers table. Is it possible for the Y to ever have parentheses around it?
No.
Okay.
These come there. So what I call them is like scrambled.
Mhm.
There's a couple other ways that these can be presented, which are scrambled, but so that -2 goes right in the middle. And this is what's a little bit
So you
awkward
put the
again.
X in the middle?
Yes.
Oh, right, because the X has to be the 0. Okay, yeah, that's a.
And you go 3 smaller and 3 and 2 larger. 2 smaller and 2 larger.
Smaller, 2 larger.
Okay, so this time again, it's -4 plus 2 squared plus 6.
So then that'll leave you with 10.
Yes. Sorry, didn't pay attention. Yes. And then y equals parentheses -3 plus 2 squared plus 6.
-1 plus 6, 7.
Okay. And then next one, -2 plus 2 squared
Negative
plus.
6.
Okay.
And then 7 again.
Okay.
Oh, sorry, that would be 10.
10. Perfect. Again, there's symmetry. These match and these match.
All right.
Okay. So the time to do one on your own, if you're okay with that.
Yeah, of course.
Okay. And if you struggle, that's okay. But at some point, you gotta say, all right, let me try and see if I can do this on my own. Y equals x minus 1 squared minus 2. So I made this one more difficult than the ones that we've been doing. Let me help you out here. The transformations are right 1, down 2.
Mm-hmm.
Can you tell me the vertex before you start?
1 and 2.
So down is negative.
Okay, so 1 and
So right is positive, left is negative, up is positive, down is negative.
is it always, so will it always have negative in the one right there?
Which one?
In the V where it's like 1 and -2, will that second number always be negative?
Well, let's go back and look. Was it negative in this one?
No, it wasn't.
It's whatever that value is. How about in the previous one? It was 1.
All right.
There's a bit more here, but I'm trying to avoid doing that formula. So what value is your table centered at?
Y equals,
X equals.
oh yeah, X equals, then there's
Give me the.
-1, -2, and then 2.
So don't forget about 0.
Okay. Do I have to?
Yeah, will you fill in this table for me? I just want the final ordered pairs. When you're
Okay.
done. Give yourself a minute to work through that.
Oh wait, I forgot to square those. Right,
Yeah,
that'll
go
be
ahead and double check your work.
okay.
All right, you think you got it here?
Yeah, the numbers seem like a little bit weird. Like I got a lot of like twos.
Okay, so let's try. I'm gonna just write them down here, and you can tell me if you don't like what you see.
All right.
So this next one is 0, and then -1.
And that's negative. Why is that -1?
Okay, let's go through it. So it's y equals 0 minus 1 squared minus 2.
Mm-hmm.
So 0 minus 1 is -1. Squared minus 2. -1 squared is 1.
-2. Okay. Maybe that's where I went wrong.
Okay. And then this one up here is -1 minus 1 squared minus 2.
Is 4 minus 2 is 2. I got that. I have, yeah, I think that was the only one I messed up on.
Okay, so that is -1, and then 2, and then this last one here ends up being 3, 2.
Okay, I got all those right except that one.
Excellent, excellent. Okay. What I would like to do is move on to another type of transformation, if you will allow that.
Yeah, of course.
Okay, and then a bit of guided practice. So I'm gonna switch sharing again. I'm gonna do a new share. I'm gonna go back over to Desmos. Okay, and this time, okay, I want to know if you know what you think. What do you think happens when you put a number like 3 in front of x squared? Do you have any idea what that does?
I guess it'll just start on the 3 instead of 0.
Okay, so now you can see it. What word might you use to for that?
Is it a third of what it is?
Okay, let's try. Let me just change this to a 2, and then let me try another one here. I think there's a bit of exploration here. So let me get rid of that one. Compared to the original, which is in black, in green there is 1/2 x squared. What do you see? Could you just describe that for me?
It's like the original is half the size.
Okay, so let's use a car analogy here. And think of like tires.
All
The
right.
tires got thinner. The tires got fatter, wider. You see that? Does that at all visualize for you?
I guess so you're like putting more into it.
Okay, I'm gonna drop the car analogy for a moment here.
Yes.
I'm trying really hard here. So, if the number is if the number in front is less than 1,
Mhm.
it stretches it horizontally.
Oh, right.
I'm sorry, or
Stretch.
not toward. It's a stretch or a compression depending on where the number goes. Okay, so this 2 is actually like pulling it up. Believe it or not. So it's a bit hard. This one's a bit harder to see, but that is what's happening. Like the number in front affects whether it's wider or thinner, sort of as a visual on it.
All right.
Is that okay? Kind of.
Uh,
It's not great, is it?
no, not too good.
Let's try another one. What does negative in front do? You can see it right here.
It makes it flip.
Flip. Very good. Now, let's say we do the following. Let's say we go negative in front plus 3. What are the two transformations that you think will happen here as a result of this? There's only two.
I think it'll flip
Flip,
and then
and then what does this
also
do?
move to the right by 3.
Is that 3 inside parentheses?
No, it is not. So
So
then
what does it
it'll
do when it's
flip
outside?
and then go up 3.
Very good. So it flips and then goes up 3. Did that flip and then go up 3?
Yes, it did.
It sure did. Okay, so let's try another one here. What does x plus 4 squared do? Inside parentheses.
X plus 4 squared becomes it stays the exact same, but it goes to the left 4 times.
Left 4 units. You got it. Now let's add in a little bit more complexity here. Let's throw the negative. Let's go plus 3. What are the 3 transformations that you see there?
It'll go. Wait, was that negative in front of the parentheses the entire time?
No, it is now. I added it. There's 3 transformations here.
Okay, so I guess it'll go. Would it go to the right 4 times now?
No, it has nothing to do that negative outside. You just hear. So there's a disconnect here. Okay, so let's piece this together one at a time before we get to this.
Okay.
So this third one, you just told me, what does x plus 4 squared do?
Moves it over 4. That plus 3 would make it go up 3 once it already moves over 4.
Okay, so now y equals x plus 4 squared with a negative in front. What does that do?
Oh, it flips it.
So notice the progression here. Sorry, let me change the color in the second one. It doesn't mesh well. So it started in the black, then it went to the blue. That was left. Then it flipped.
Okay.
Okay. So then what is the plus 3? What's the last piece?
It moves up 3.
Up 3. So black, and then it moved left
to blue.
Then it flipped,
red.
and then it moved up.
Okay.
Now, sometimes your instructors, believe it or not, will have you graph like all of the progressions. We want you to graph it at the end. We want you to say the 3 transformations or 4 or however many it has and be able to graph it there at the end. Okay.
Okay.
So let me give you another try here, another crack at a problem here.
So it's almost like programming in a way?
In a way, yes. Okay. So let's go x minus 5 squared minus 4, and let's put a negative in front. And I didn't mean to do that. Hopefully you didn't see too much of that. Okay. What are the 3 transformations of this one?
So since it's negative 5 squared in the parentheses, it has to move to the right 5 times. Then
which way is it going, left or right 5?
It is going right.
It is going right 5. I agree.
And then once it hits negative 4.
So the next one is actually this negative.
Oh, right. Then it flips from what it currently is. And then that negative 4 will make the vertex move down by 4. So 4 numbers.
Okay, so the only thing I'm going to do, and this is a small like little wrinkle change, is you want to say flips or the word reflects over the x-axis.
Flips over the x-axis.
Here's the x-axis right here.
Flips.
But that has to be in your, like if you were in my classroom, which you're not, but if you were, that would be important to me. You may have to ask your instructor like, hey, is it okay to just say flips? Because in truth, you could actually flip over either axis.
Mm-hmm.
Okay, but we don't need to make it too complicated as of yet.
Okay, so then.
All right, so here's what I'm going to do. I'm going to give you three problems here, and I want you to give me the transformations for each of them.
All right.
Let me get it, man. I'm not even close to
being I won't look at the screen for a little bit.
Oh no, you can look. I just I'm not going to I'm not ready to I'm not finished with them yet, but let's do that. Okay, so there's 3 problems there. I want you to give me the transformations of each one. Take about a minute. I'm going to step aside for a minute and I'll just check back with you. Okay.
Sounds good.
Thank you. All right. How are you doing on this one?
Just about to finish the last.
Okay.
All right, just finished.
Okay. So for the first one, give me the 3 transformations, and order does
Left,
matter.
2
Yes.
up, and then
Wait. I'm sorry. We're talking about this is the first one, right?
yeah.
Okay. How many left or right?
You will move to the left 2 times.
Left 2. And then what does this negative do?
It'll flip it.
Reflects over the x-axis, and then minus
Right.
3. What does that do?
Reflect over the x-axis, and then the 3 will move it down by 3.
Okay. So let's see if, so we're looking for left, flip, and down. There it is. It
All right.
went left, it flipped, and it went down.
Mhm.
Okay. So again, like you, and I'll try to give you a little more information, but how about the next one here? What do you see here? What does this -1 do?
It'll move to the right 1,
Okay.
flip over the x-axis,
Okay.
and then move up 1.
Okay. So it's right, flip, up 1, right, flip, up 1,
Right flip.
right, flip, up 1. That sure looks good to me.
All right. And then
How about the last one?
left by 3,
Okay.
flips over the x-axis.
Where's the negative?
Before, after the,
So the negative has to be in front. Do you see the difference between these?
yeah,
So this one does not flip.
because there's no equals.
There's no negative in front.
Wait, is that an equal sign or a negative?
Yeah, it's an equals.
Oh, okay. On my screen, it's a negative.
Okay, we're looking at the third one, I hope.
Yeah,
But
that's what
okay.
I don't know. That's weird. It's
I mean,
still
after it's oh, well, that's interesting. Yeah, maybe it's just there's aliasing.
all right. Let's just say that's not there. So it'll go to the left 3
Good, and
then down by 4.
very good, perfect. Okay, so let me go back to our other workspace here and try to explain like why the order matters here, or how I know the order. So let's say it's negative x plus 2 squared minus 3. If I asked you to evaluate x equals 0, what would you do first after you put the number in for x? Meaning, like, what's the first calculation that you do? Do you negate it, add it, square it, or subtract?
I guess. Wait, what would the inside the parentheses be called?
Yeah, order of operations tells you to do what's inside parentheses first.
All right. So then you would have to move it.
You would add 2 first.
Okay, so 0 plus 2.
Right.
Okay,
So when
0
because
plus 2.
hang on. Because you're adding 2 first, that's why the first transformation is left 2. Because you're actually evaluating this part first.
All right.
Okay. So then you square it, right? Because that's order of operations.
So then,
So see how the negative gets applied next?
mhm. So
That's
you
why the
first
second
use
one is the flip
this and then apply.
or reflect over the x-axis.
All
And then,
right.
and then what's the last thing you do? You subtract 3.
Mm-hmm.
That's why it's then down 3. So the order of the transformations is literally the order that you evaluate the quadratic in.
All right. Okay, so there's like a negative, so that's why it's like opposites.
Yes.
Okay.
Yes. Okay, so kind of last little thing here, and we tried to do it with Desmos, but it didn't really go well. X squared, y equals kx squared. So there's two possibilities here. If k is greater than 1, it's a vertical stretch. And 2, if k is between 0 and 1, it's a vertical shrink or compression. You may check with your instructor for which word he or she likes on that.
All right. I think she uses shrink.
So let's do an example. Let's say, I know you probably, I'm rushing here a little bit at the end. Let's say it's y equals 3x squared. Okay, we would say it's a vertical stretch by a factor of 3.
Vertical stretch by factor of 3. So then.
So let's say it was y equals 6x squared.
6x squared.
It's a vertical stretch by a factor
of 6.
of 6. Now, this is not the same, but let's do this real quick. Y equals negative 2x squared. There are two transformations taking place.
So
The first is a vertical stretch
by negative
factor of 2, not negative 2.
Of 2. So I would not write it as negative. And then
flip / reflect
okay.
over the x axis.
All right.
Now, just in full disclosure, I've intentionally avoided talking about some of the oddities or like the wrinkles and the warts of these types of problems. So there's like more to come. Like I've sheltered you, I've given you 80%. There's a bit more here. So don't, even though you did a great job today, don't, there's more. So don't go to make sure you're still paying attention in class.
Yeah, of course.
All right. Well, that does take us to the end of our lesson for today.
All right.
Zach, thanks so much for scheduling. I'll send you the notes here shortly and I'll see you next time.
All right. Thank you, Matthew.
Have a great night. Bye now.